Hi everyone and welcome to the Universal Camera plugin overview. What you're seeing right now in the background is the demo for the Universal Camera. You can find it in the description of the video if you want to try it. So as you can probably tell by the length of the video, there are a lot of stuff to cover. So feel free to jump to the different chapters of the video, which you can find in the description as well. I will try to cover as many features as possible, so let me know what you think in the comments. Yeah, see you right there. So first make sure the Universal Camera plugin is enabled. And we're gonna create a new blueprint class from the Universal Camera class and call it Universal Camera BP. Now open it and you'll see that it doesn't come with a camera by default. You will need to add your own, so make sure to select the spring arm component and click add. And this way you can add a cine camera if you want, but I'm gonna go with the regular camera. Now open your game mode and set it as your default point class. And now if we hit play, we can see we have the universal camera in the level, and the yellow debug sphere here represents the origin of the camera. Now I'm gonna show you a quick way to set up your inputs in order to be able to move around using a keyboard or a gamepad. So go inside Edit, Project Settings, Inputs, and here I already set up some inputs. We have move forward, move right, rotate yaw, rotate pitch, and zoom in. So I'm using a French keyboard, so some of those keys may vary for you. And don't forget to put the -1 scale on the opposite keys. And I'm also using some gamepad inputs. For zoom in, I will be using the mouse wheel axis. Now open your Universal Camera BP. And for each different binding, you will find a corresponding function. And you just need to link the axis value. And repeat for each different keybind. Once done, you can hit play. And now we're able to rotate the pitch, rotate the yaw, zoom out, zoom in, and move around. There are a lot of different tools and ways to move the camera around. So first I'm going to go over the class defaults, and in here you'll find the Universal Camera plugin category, in which you'll have a bunch of different settings. I'm going to go over them one by one, but you can jump to the different timestamps of the video. So first we have the features. Those are the features enabled by default. So if I uncheck movement and rotation, for example, I won't be able to move or rotate until I re-enable them. And to do this during runtime, you can use the enable features function and disable features. So you just check the features that you want to enable or the ones that you want to disable. Next we have the starting position. This allows you to override the starting location, offset, yaw, pitch, and zoom using the class default. So if we want our zoom to start at 1000, for example, we just check this and set our value here. Next we have the basic movement and zoom. In here we have the movement speed, offset speed, rotate speed, and zoom speed. The offset speed allows you to, the offset allows you to move the camera around without moving the origin. So let me show you. Go inside your move forward and move right functions and check the offset. And now if we hit play, we are able to move the camera without moving the origin. So this can be useful if you're following an actor. The origin will follow the actor and you will still be able to move around that actor using the offset. Up direction is absolute, means that if you're using the move up function, you will only be moving on the Z axis. So let me show you. Let me set an input for that. I'm gonna create a new input called move up. I will be using the spacebar and left control with a -1 scale. So I get my input here. And now I can move up and down. Only on the Z-axis, as you can see, even if I'm at that angle. And if I uncheck it, now I can move up and down on those axes, depending on my angle. Inside basic movement and zoom, we also have movement scaling. This allows you to adapt your movement speed depending on your zoom level. So if I check this, you can see as I'm closer to the ground, I'm going to go slower, and as I get further away, I'm going to go faster. You can also apply it to the offset or move up. So by default, it's using the zoom level, but if you uncheck this, you will be using the height of the origin, so the distance of the origin from the ground. You have a minimum and maximum movement speed, so if you don't want to go too fast, even if you're really far from the ground, you can put a maximum speed here, and something for the minimum. You have a scaling distance reference, so if your zoom level is enabled, it's going to be the default zoom level at which you will go at the normal movement speed. So if you have a zoom level above this value, you will go faster than this, and if it's below this value, you will go slower. If you're using the origin distance from the ground, so if you uncheck this, you can also feed a ground level. So if you know your level height is not going to vary too much inside your level, you can put an arbitrary value here. So let's say my ground is at 100 units. But if you have an irregular terrain, you can also trace to the ground by checking this and selecting a channel, and this will just override this value. Most of the time you will probably be using the zoom level, so you don't need to care about the ground level or the scaling trace to ground. You have the same thing for the zoom. The zoom scaling is enabled by default, so this allows you to be more precise as you are closer to the origin, and zoom way faster as you get further away. And you have the same type of settings, so you have a minimum and maximum zoom speed and a zoom reference. Next we have restrictions, which allows you to put constraints on your camera for your location, offset, your pitch and zoom. So you have by default minimum zoom set to 0. And you can do something for the yaw and the pitch. And for the location you have a raw, which means that you will be able to put a minimum X, Y and Z value and a maximum X, Y and Z value. So for example, if I check this, put -500, -500 for my minimum X and Y, and 500 for maximum X and Y. Now it's just gonna draw a square on the map, and I won't be able to go outside of that square. So if you have a rectangular shaped map, you can use this method to set some boundaries to your map. And you can do the same thing for the offset by selecting custom and filling these settings. For the offset, you can also select max distance. Instead of putting minimum and maximum X, Y, and Z values, you can just put a maximum distance from the origin. So here I won't be able to go further away than 500 units from the origin. So I'm going to check the offset. So this can be useful if you're once again following an actor and don't want to go too far from the actor you're following with your camera. So basically this value will be the radius of the circle around your origin. Now for the location you also have dot shape. This allows you to draw a shape depending on 2D locations, and your camera won't be able to go outside of that shape. So here, for example, if we have 3 elements, it's going to draw a triangle, but you can put as many as you want. The only thing that is really important is to place them in the right order, because it's going to draw edges from 2 points each time, so from this one to this one, then this one to this one, etc., and circle back to the first one. So you can either enter them manually, but this can be a bit tedious. The best way to do this is actually to create actors, place them inside the level, and then fit their locations in here. So I'm gonna create a new actor. I'm gonna call it an actor dot location. I'm just gonna put a sphere in order to see it, but you can set it to hidden in game if you want. Now I'm gonna drop some of them in the level and draw a shape like that. So this can be my shape from here to here to here to here to here and circle back here. So I'm gonna open the level blueprint, and on begin play I'm gonna first get a reference to my camera, so universal camera BP. And the variable I need to set is this one, constraint dots. So I'm just gonna set constraint dots. You can see we have a function for this. So now I need to convert my actors to 2D locations. So I'm gonna drag my universal camera BP, and we have a function called get actors location 2D. This will convert an array of actors to an array of 2D locations. So now I just need to feed an array of actors. I believe we have 6 different actors in the level. I'm gonna reduce this, and I'm gonna just place a reference to each of these. Okay. So the important thing is to put them in the right order. So it doesn't matter if you start with this one, or this one, as long as you draw the right shape in the right order. So two locations next to each other in an array means it's going to draw an edge from them. So if I put this one, then this one, then this one, then this one, it's going to draw a really weird shape, and it won't work like intended. So just put them in the right order in order to draw your shape. Okay, and that's it. Now we can hit play. Oh, I think I'm still moving the offset. Yeah, so if you have this checked, just uncheck them. And now you can see I can't get outside of that shape. I'm still able to slide along the edges. So this can be a quick way to set the boundaries of your map. You can have as many dots as you want. Okay, I'm just gonna remove those for now, so I'm gonna delete this and uncheck constraint location to shape and remove those dots. So next we have auto positioning. So we are done with basic movement and zoom. So for auto positioning, this allows you to adapt your camera height to the terrain. So let me just show you. I'm gonna select a channel and I'm gonna enable it here in my enable features, auto positioning. Now you can see that my camera height is gonna adapt to the terrain. So here we have the auto positioning channels. Here is the distance from the ground of the origin itself. So at 0 it will just stick to the ground and you can increase this value. The Z probe radius is the radius of the trace. So here you can see I'm not exactly on the surface, but it's gonna still detect it. So if you want to be more precise, you can increase this value, decrease this value. But if you have a very irregular terrain and you don't want your camera to flicker up and down each time, you can just increase this value. Can go below surfaces. This allows you to go below certain surfaces if your camera height is below it. So here you can see my camera height is below this surface. I'm able to go below it. And if I put my height above it, now I'm adapting to it. And if you want to always check for the highest ground, you can uncheck this. And you will always go to the highest surface no matter what. Always see origin. So let me show you how that works. You can see if I put my camera here and rotate to the left, no, I'm not able to see my camera origin. Maybe I want to adapt to the terrain as I'm rotating to the left here because I can't see the origin. So you can check this. And now, as I rotate left, it will adapt to the height of my terrain. So you can do this and you have a visibility probe radius for the origin. Distance adaptation means that at certain heights you won't care about the auto positioning because you're already too far from the ground. Let's put a value here. So this is the distance from the ground at which it will just ignore the auto positioning. So here I'm adapting to the terrain. And as I get far from the ground, now I'm just ignoring the auto positioning. Yeah, so that's it for the auto positioning. I'm gonna disable it. Next we have edge scrolling. We'll need the mouse for this, so I'm gonna show the mouse cursor. So set show mouse cursor. So the edge scrolling allows you to move the camera when your cursor is close to the edges of your screen. Pretty common in RTSs. So I just need to enable it, edge scrolling. And if I hit play, you can see now as I'm getting close to the edges, I'm moving my camera. Here we have some scaling for it. You can see as I'm further away to the edges, I'm going slower and I get faster and faster as I'm getting closer to it. So this can be modified. We have some settings. We have edge scrolling sensitivity is the distance from the edges you will need to be to trigger it. A speed multiplier because it's using the movement speed. So you can add a multiplier to it if you want to go faster than the movement speed or slower. You have a strength, so this allows you to add some scaling. I'm gonna disable it and just put a kind of a standard RTS edge scrolling. So put a low value here and disable the scaling. Of course, this works way better in full screen, because here, if I go too close to the edges, I'm actually going out of the screen. So try this in full screen; it's way better. And you also can apply this to the offset if you want. So during runtime, you can just set this value to true or false. If you want to add some widgets or modify your cursor, you can do this with some events. For this, we have on begin edge scrolling, on update edge scrolling, and on end edge scrolling. So this can be used whenever it's triggered. So this way you can create your widget or modify your cursor. This is updated on each tick while you are edge scrolling, and you will have a direction, which is just a 2D vector, but you also have simplified direction if you prefer. Here you will have right backward, right forward, left forward, left forward, and backward. So this can allow you to set the direction of your widget if you want. And finally, you have an end edge scrolling. So here you just set back your mouse to default or whatever. Next, we have the precise mouse drag. So this allows you to drag your camera around like that. So I'm just gonna put a key here, left mouse button. You can also set it in your inputs if you want. And you just need to toggle precise mouse drag. Activate it on pressed and deactivate it on released. And now you can see I can drag my camera around. And it's called precise mouse drag because if I select an intersection here, for example, right there, you can see my mouse will go back to the same location each time. So you have a collision channel because it's tracing to the ground. Because I can't do this with math because there are some moving functions that the user can override, so I need to do some tracing to achieve that. So you can check trace complex if you want. You have ignore movement lag, so this will just ignore the lag. You'll see the difference. If I disable it, it's smoother. Now I'm going to show you how to create your own mouse drag logic, and this way you'll see that you can actually create your own logic once you start to understand the different functions. So we're just going to use the left mouse button again, and we're going to create a new boolean called is mouse dragging. Set it to true on pressed and false on released. Again, you can set it in your inputs as an action mapping. We're gonna listen to the mouse Y and mouse X values. We're gonna make sure that we are pressing the left mouse button, so we are actively trying to mouse drag. And we'll use move forward and move right. Now we actually need to multiply it by -1 because else we are going in the wrong directions. Like that. So you can try this, but we can see that we are going pretty slow. So we can create our own speed variable, create a float. we'll call it mouse dragging speed, and feed it inside the multipliers of the move forward and move right functions. We're gonna set it to 2.5. Now it's a bit better. But maybe we need some scaling for it. So since we are using the move forward and move right functions, it's actually gonna use those settings. So we have the movement speed, for example, but it's also gonna use the movement scaling. So we can also add some scaling to our mouse drag function. So we're gonna check this. And now it's gonna adapt to our distance from the ground. So there are still a lot of improvements to make, but this is a good start if you want to start trying to create your own logic. Now I'm going to show you how to do something similar, but in order to rotate around a certain location using your mouse. So we'll use the function rotate yaw around pivot. And this is similar to this one, except you will have a location here. So we're gonna use the left mouse button. On pressed, we're gonna set a boolean. We'll call it is rotating around pivot. Set it to true on pressed and false on the list. Now we're gonna listen to the mouse x-axis. Make sure that we are pressing the left mouse button. And now we'll need a pivot location. So we are just going to take the one under our mouse cursor. We have functions for this. Get impact point under our cursor. We're going to make sure that we hit something and store that location. I'm going to call it pivot location. Actually, let's make sure that we hit something before we start activating the rotation here. So we'll do something like that. Okay, we can link the axis value, and we can also here link our pivot location. We can modify this multiplier or create a variable if you want to control the speed. And now I can select a location and rotate around it. I'm gonna increase the speed a bit. So I can rotate around that object if I want. And you can also do something with the pitch using rotate pitch around pivot. Next we have the screen sliding. It allows you to move your camera with your mouse in a similar way as when you press the middle mouse button on your browser. Something like that. So for this we'll use the middle mouse button and we just need to toggle screen sliding. Activate it on pressed and deactivate it on release. Now you press the middle mouse button and set the origin, and as my mouse gets away from the origin, I'm gonna move the camera as well. Actually, we can't see the origin. That's because we didn't set a sliding origin widget class. So we are gonna create one. I call it sliding origin. And we'll just need an image. And I already have a texture here, cardinal arrow. You can use whatever you want, of course. Resize it and set it as the sliding origin widget class. So we have some settings for this. We have the maximum speed. This is the speed multiplier, the maximum speed multiplier once you reach the maximum ratio. The maximum ratio is the maximum effective distance from the origin of the screen sliding. So once you're at 0.2 or more, you will go at the maximum speed multiplier. And you can change these values if you want. You can invert the X and Y axis, and you can also use this to do some rotations as well. You can move the camera, the offset, or rotate the yaw, the pitch, or both. So if I select yaw and pitch, now I can rotate my camera using this. Next we have the lag. This is what controls the smoothness of your camera. So as you can see, we have a yellow and a green debug sphere, and the yellow one is the desired location of your camera, and the green one is the actual location, current location of your camera. And so your current location will always try to reach the desired location, so the yellow one. And this is what is causing the smoothness of the camera. So if I were to disable it, I will just disable the lag. So now I no longer have a green debug sphere because my desired location will always be the same as my current location. And you can see the difference. So you can adapt the smoothness of your camera by playing with these values. A lower value will mean that you will take more time to reach the desired location. And a higher value will mean that you will go faster to reach the desired location. So here it's almost as if we didn't have a lag. We can put 10. So yeah, play around with those values. I'm usually using 5, it's the default, but you can put the value that you want, it's up to your preferences. And finally we have debug, so this is just if you want or not to draw the debug spheres. So now we're done with the settings, but there are still some things and some tools that we didn't see. So I'm gonna show you. So for example, you may wonder how to set the actual location of your camera using Blueprint. And when we're dealing with actors, we usually use set actor location, for example, and for the rotation, set actor rotation. And to modify the zoom level, just set the target arm length or the offset with your spring arm component. But with the universal camera, we will never use this. Instead, we'll use set desired location. Set desired location for the location, set desired yaw, and set desired pitch for the rotation. You can set desired offset, and you can set desired zoom. And if you want to do them all at once, you can set desired position. So forget this forever when you're using the universal camera, and instead go for this. This will allow you to take the lag into account, and even if you're not using the lag, I strongly recommend to use this instead of using set actor location, set actor rotation, etc. So yeah, use this instead. So let me show you with set desired location. I'm gonna use the C on my keyboard. I'm gonna try to 100, 100, 100. And now it's going to go straight to the location, applying the movement lag if it's enabled, or else it will just teleport to it. Now if you want to smoothly travel to a location, you can use travel to location and travel to actor. So this gives you more control over your traveling process, and you also have events whenever you reach the destination or cancel the current travel task. You'll use travel to location most of the time if you want to travel to a location or an actor that isn't moving, and if you're traveling to a moving actor and want to track its movement, you'll use travel to actor. So you just need to feed the universal camera. Here with self, we'll travel to 1000, 1100. You can feed your pitch and zoom settings, but if you leave them empty, it will just stay at the current yaw pitch and zoom of your camera. You must feed a curve for it to work. So normally you have two curves I created on the plugin content, but it doesn't show on UE5. I don't know why, but you can quickly create one. Miscellaneous curve float. I'll call it S curve, because we are gonna give it the shape of an S. And you'll need to add two keys. The first one at 0, 0, and the next one at 1, 1. So here we have a linear curve, and we want to form a shape like an S, so we'll use cubic interpolation and toggle weight tangents. Drag them like that. And here we have our shape. We'll use this. So this way we will go slower at the start of the traveling, faster in the middle, and slower near the end. So we're gonna feed it here. You can leave the speed settings blank. I think by default it's using a duration of 2 seconds, but you can also use a speed if you want. We'll use a speed of 1000 units. And let's try that. Now if I press C, I'm gonna travel to the location. So you can see we go slower at the beginning, faster in the middle, and slower when we are near the target location. So let's say we wanted to modify these values. You can just drag them and you will find use target value. So if I were to do that, here it will set my yaw pitch and zoom at 0. I will just use the current yaw and pitch, and for the zoom I'm gonna set it to 2000. I'm gonna print something whenever I reach the destination, and whenever I abort the travel task. Now I will need something to cancel my traveling. I'll use V, and I will just need to call abort travel task, like that. So now it will travel to the location, set my zoom at 2000, using the curve as well, and I reached the destination. Now if I want to cancel it, I press V, and I aborted the travel task. You can also use a placeholder camera to travel to a specific view. For this, you just need to create a new blueprint class from the placeholder camera class. I'll call it placeholder camera BP, and you can place it inside your level and set your angle. I'm gonna set something like that to look at this magnificent geometry. You can set the target arm length here. I'm gonna set it to 2000 and move it a bit like that. Okay. So we're gonna travel to that specific position, so the location, the angle, the zoom level, etc. You can use your level blueprint to get a reference to it, but since I'm only using one, and to show you quickly, I'm going to use get actor of class. This one. Get my placeholder camera BP. And now I can use the function get info. So I can split this and we have a location, yaw, pitch and zoom. I'm gonna fit the location. For the yaw, pitch and zoom, you'll use target value. I'm gonna copy and paste and fit them like that. Okay, let's try this. And now I press C and we're gonna travel to the position of our placeholder camera. So this is the same view that we had with our preview here. Now before I show you how to travel to a moving actor, I will first show you how to follow an actor. And for this, we'll just use follow actor and stop following. So I created a simple character that is moving around. And we're gonna follow it. So if you spawned it yourself, normally you will have a reference to it. But here, just to show you, I'm gonna use get actor of class. Third person, no, it's top-down character. Just follow it like that, and V to stop following. Now if I press C, my camera will go straight to it, and it will try to reach it using the movement lag. You can disable the movement lag while you are following an actor if you want. So I'm able to zoom, to rotate, but I'm not able to move my camera because right now I'm trying to move the origin, and the origin will always be at the same location as the actor. So what we may want to do is to move the offset instead of the origin while we are following this actor. So for this, go back to your move forward and move right functions. You have an offset boolean, and we're going to use is following any actor. And this way, if this is true, if we are following an actor, we'll move the offset instead of the origin, and if this is false, we just move the origin as usual. Let's try this. I will press C. Now I'm following it, and I'm able to move my camera around the character. Now the issue we may have is, if I follow the actor, move the offset, and stop following it, you can see that it will keep my offset. So I will want to reset my offset whenever I stop following the actor. For this, I will just use reset offset. And now, if I move my camera offset and I press V, I will go back to the default offset, 0, 0, 0. Now let's say we first wanted to smoothly travel to the actor before we start following it. For this, we could use travel to actor. And only whenever we reach this destination, we'll start following the actor. We'll use self for the universal camera. The target actor is going to be this one. I'm going to promote it to a variable. I already created a variable actor to follow, I called it. We won't use the target URL pitch, it will not make much sense for our camera, same thing for the zoom. We are gonna use the S-shaped curve again, and this time we'll use the duration of 2.5 seconds. Let's try this. I will get further away, and if I press C, I'm gonna travel to the actor and then start following it. Now if I press V, I can still move the offset, and if I press V, I stopped following it. But the thing is, if I'm trying to stop following it while we are in the process of traveling to it, it won't work. So I will need to wait until I follow it, I reach the destination, press V to stop following it. So for this, we'll want to abort the current travel task whenever we press V as well. And now with V, I can either stop the current travel task or stop following the actor. I stop the travel task. Now I press C, I press V again, I stop the travel task. There's a function called getActorFocusLocation, and this will give you the ideal location and zoom in order to fully see an object depending on your rotation, of the rotation of your camera. So actually, let me show you. This will be more explicit. I'm gonna create a new actor called Focus Cube. It will just be a big cube. Like that. I'm gonna place it inside the level. So it's floating a bit. I can just put it like this if I want. And once again, if you spawned it, you will have a reference to it, or else you can use the level blueprint to get a reference, but I'm just gonna get actor of class. Cube, focus cube. I'm gonna feed it here, and I'm gonna set desired location, and set desired, not offset, zoom. I'll fit the location and the zoom. First I will make sure that we found something. I could also make sure that this return something, but I'm gonna press C with this angle, and I'm getting the right location and zoom to fully see the object. Even if you have weird angles, something, I don't know, thing like this, now I will be on top of the cube to fully see it. So yeah, this can be useful if you want to get a focus to a specific actor. Let's try with this angle. So if it were bigger, it would just adapt to it. Now I will press C. I can see it fully. We can also travel to location to travel to this actor. I will use all of the defaults except for the location and the zoom. I will press C. And I'm focusing this actor. You can save and load the position and the settings of your camera using get save format, those two functions. And load save format to load them. So the position is the current location, offset, rotation, and zoom level of your camera. And the settings are all of those values. So this way, if you allow the player of your game to modify some of those settings, like the rotation speed or the zoom speed, you can save his settings and load them. So to do this, you'll need to create a new blueprint class from the save game class. I'll call it mySave. So in order to save the position save format, you need to create a new variable from the position save format structure. I call it position. And to save the settings, you will need an array of bytes. I'll call it settings. Now go back to the event graph of the universal camera. And we just need to create the save game object from the class we created. So mySave. We set the position and the settings. So we'll just set those two variables. Feed the position and the settings save format. And next you'll need to save game to slot. You can put a slot name and a user index. And that's it to save both the position and the settings. But of course you may want to only save the position or only save the settings. It's up to you. Now to load, you'll use load game from slot. But our slot name, you need to cast to your save game class and get the variables, so position and settings. And now we'll just load the position and the settings like that. So that's it to save and load. You can also change the behavior of the camera by overriding some of its functions. So go inside functions override and you will find some functions tagged as universal camera. So for example, we can override the way the AutoPositioning works. This is this function, set the desired location. We can change the movement scaling, the zoom scaling, a bunch of different features. And let's say we wanted to change the way the movement lag works. We can override lag get tick desired location. So on each tick, this will be called, and basically we will have our current location, which is get actor location, and on each tick we want to get closer to the desired location. So right now the return value is returning 0, 0, 0, so our current location will always be at 0, 0, 0. We'll be able to move the desired location, but we won't be able to catch up to it. Let me show you. So here I have my desired location, I can move it, and here the current location at 0, 0, 0. So we could use a linear interpolation from our actor location to the desired location and fit the delta time for the alpha. Now let's try this. So it works, but you can see it's a bit slow. And the nice thing is that we can still use those values. So we're gonna use the movement lag speed in pair with our own method. I will multiply the delta time by our movement lag speed. And now we created our own movement scaling method while still using this value. So we can try with 4. It's better. So I think we've covered pretty much everything. I really hope you enjoyed this plugin, and feel free to reach out to me if you have any question or want to see new features. And yeah, have a good one. Bye.